Hi everyone, welcome back to week 2. Woo woo. This week we're going to be focusing more on things that we've already learned. And so I wanted to do a review and extension on central angles and arcs. If you've noticed, my circles got a lot better. I brought home this circle to trace it. I know my circles on the board are not very good. Oops. But I wanted to remind you what central angles and arcs are and the relationship between them. So, an arc is this thing right here. It's on the outside between 2 points. This is an arc, and this is the central angle. And the special relationship between an arc and a central angle, do you remember that? The special relationship is that they are equal. So the measure of a central angle equals the measure of the arc. So the measure of the central angle equals the measure of the arc. So let's review a few things. First off, we have these things called minor arcs. Do we think minor means big or small? A minor arc is a small arc, meaning it is less than 180 degrees. So an example of a minor arc would be arc MP or arc PN. These arcs are less than 180 degrees, and we use 2 points to name it. The opposite of a minor arc is a major arc. Do we think major means big or small? It means big. So it is an arc that's greater than 180 degrees. And we use 3 points. So for example, that might be arc P, M, N. So we could say arc P, M, N is a major arc because it is bigger than 180 degrees. It's this huge arc right here. And so for a major arc, we use 3 points. The last type of arc that's really important in solving these problems is the arc that's made with a diameter. A diameter arc, which is also, this might be a new word for us, called a semicircle. Can we say that? Semicircle. And a semicircle means that it equals 180 degrees. It is 1/2 of a circle. And that's this right here, this line that goes through the center. That means that this arc on this side is 180 degrees. It's a semicircle. It's half of a circle. It's a diameter. And we actually, for a semicircle, we would just name it 2 points, arc MN. It can just be 2 points. So now we remember naming them. We remember that the measure of a central angle is the same as the measure of the arc. We also remember that a semicircle, a diameter, is 180 degrees. I think we have enough information to do an example. So let me move this up. And let me draw a nice circle. So much better than the circles on the board. We'll find the center. I'm gonna draw this line. It looks like a diameter to me. And then I'm gonna draw a radius and a radius. This is gonna be A, B, C, D, and we'll just name the center E. And I'm gonna tell you that the central angle AEB equals 151 degrees. And what I want you to be able to tell me is, what's the measure of arc AB? What's the measure of arc CB? And what's the measure of arc AC? All right, so let's give it a try. I'm gonna grab this. Arc AB goes from here to here. What do we remember about an arc and its central angle? They are equal. So if the central angle is 151 degrees, the arc is also 151 degrees. That one's nice and straightforward. Next up, we have arc CB. That's right here, CB. How can I find this? What do I know? Yeah, you might notice I have this line. This is my special diameter line. This means it's a semicircle. It means that this whole angle right here is 180 degrees. So in order to find CB, I'm going to take 180 and I'm going to minus what I already know. I already know 151 degrees. That's arc AB. So BC has to be what's left, and that is 29 degrees. Cool. And the last one is AC. I'm out of highlighters. But AC goes from here, from A, all the way to C. What's AC? What's this whole side of a circle? Yeah, half of a circle is 180 degrees. Cool. All right, I'm going to do one more example, and then I think you should have a big enough foundation based on what we learned earlier in the school year and these review examples. But here is our last example. Example 2. Let me take my circle again. I should bring one of these back, huh? A big circle back. That way I can make much better circles in the classroom. All right. So I have a line connecting, going through the middle. That's a diameter. And you know what? I'm going to have 2 diameters this time. This is going to be R, P, Q, S. We'll name the center T. And all I'm going to tell you is that this central angle is 40 degrees. And so what I would like is arc RP, arc SQ, arc RQ, and arc PQS. So first up, RP, Well, this arc is the same as its central angle, which is 40 degrees. Arc SQ, where's SQ? SQ is over here, right here on the bottom, which is vertical. It's across from this. Oh, sorry, let me show you. It's across from this, which means if this angle is 40, vertical angles are equal, which means this arc is also 40 degrees. So 2 of them are done. All right, let's do it. RQ. R all the way to Q. Well, this is a diameter, which is how many degrees? 180. All right, this last one I'm going to use my highlighter for. PQS. I start at P, I go to Q, I go to S. Yeah, it looks like it is the other diameter. It looks like it's the other diameter, so it's still 180 degrees. What if I wanted arc P, Q, R? P, Q, R. Now I want to go P, Q, all the way to R, all the way to here. I want this whole arc, that whole angle. Well, that's almost a full circle. It's everything but how many degrees? 40. So a full circle is 360 minus 40. Well, this is 320 degrees. And that's what I got for you about central angles and arcs. Please now take the time to go and do the practice problems that are with this, which is the quizzes assignment. This is all part of assignment 2. So this can all be found under assignment 2. These notes will be scanned into our Google Classroom. That way you have access to them. If you have any questions, please, please, please email me. Bye, guys.